The universal static grid of dark matter tries to maintain its static charge equally distributed throughout its individual particles as a calm electrostatic equilibrium. However, when four GNR particles electromagnetically bond together to form a proton, this creates electrical resistance in the surrounding particles of the universal static grid of dark matter. The formed proton as a unified entity demands more static charge to maintain its electromagnetic bond, and the surrounding non-GNR particles of dark matter must supply this resistance with its energy demands, which is the electron function. A hydrogen atom, which consists of a single proton, is surrounded by the appropriate number of neutrons, which make up a single electron function shell of a single proton atom. In multiple proton atoms, there are more numerous neutrons surrounding the multiple protons comprising these more complex atoms. This multiple proton atomic situation creates a larger electron function shell around the proton. When there are multiple protons demanding their individual strong force energy delivery inside this larger electron function shell of neutrons, this causes more numerous electron function pulses to occur in the same amount of time when compared to an atom comprised of a single proton. The more numerous electron function pulses occurring into a multiple proton elemental atom in the same amount of time causes us to detect the electron functions at farther distances from the atom's nucleus, and thus why we consider multiple proton atoms to have more numerous and more distant electron function shells. In multiple proton atoms, what we are actually detecting is the higher resistance in the surrounding non-GNR particles of dark matter. As they funnel or focus the more numerous cycled pulses of static electric charges into the multiple proton atom to meet the higher energy demands within this larger electron function shell in the same amount of time.